Hey, hello guys. So this is Tangadurai. Welcome to Network Beats. So in last video we have seen different type of BGP messages and different neighbor states which a router will undergo during the BGP process, right? So today we are going to do practical configuration by doing that on the JNS3 routers, and we'll see what are the messages are getting exchanged during the process of building the neighborship, either eBGP or IBGP. It doesn't matter since the messages and the neighbor states are same for all type of BGP neighborships. Okay, it doesn't matter whether it is IBGP or eBGP, but in this video we are just going to see how to configure IBGP and eBGP and the messages what it exchanges during that process. Also we are going to sniff the packet and see what type of messages that we are looking into it. Okay, let's get started. So this is the topology that we are going to work on. I have router 3 and router 5 in autonomous system number 35. So router 3, router 5 forms a IBGP relationship, and router 3, router 4 forms eBGP neighborship. Why? Because router 3 belongs to autonomous system number 35 and router 4 belongs to autonomous system number 400, which are not same. That is why we call that as eBGP. When the autonomous system number is same for both the router, then it is called the IBGP neighborship. All right. Okay. So let me start with a configuration. Here the IP addresses are already pre-configured. Show IP interface brief. Let's look into it. Okay, I have the loopback configured. Also the physical interface is configured. Let's check with router 4. Yeah, it's there. And router 5. Okay. So before getting into a BGP config, I just want to brush up one topic what we have discussed in our last video. Okay, let's consider there is router 1, router 2, and they are connected each other. Okay, uh, let's say both are in AS 100. Okay, that's good. Now I have a loopback configured in router 1. Also, I have a loopback interface configured in router 2. Okay, let's call loopback 1.1.1.1. Here let's call the loopback 2.2.2.2 slash 32. Here also slash 32. Okay, and in between let's say that we have a subnet 12.0.0.0 slash 24. Okay, here I have told you guys that BGP uses the transport protocol called TCP, Transmission Control Protocol. This is the protocol which is used for in the transport layer for the BGP, right? Okay. So before establishing a BGP neighborship, first a router 1 and router 2 will try to finish a TCP three-way handshake protocol. If that three-way handshake process is completed, then only actual BGP messages will start getting exchanged. Okay. So also I have told you the port number what BGP uses is TCP 179, right? Sorry for the bad handwriting. I'm using my mouse to write on the paint, so bear with me. Okay, that means router 1 will try to send a TCP SYN message on port number, okay, for this particular neighbor, whichever is defined in our configuration, on destination port as 179. So what will be a source port? Source port will be a random port number, okay, that will be randomly generated by router 1. Okay, we'll see this process. So how the TCP three-way handshake is happening between R1 and R2, and once it is completed, then how the BGP messages are started getting exchanged, and how they are finally establishing a full-fledged neighborship between R1 and R2. So the topology what we are working on here is this one. Okay. So let's start with our configuration. So first, here between router 3 and router 5, I'm trying to form a BGP neighborship. Okay. And now let's say that uh, first my objective here is I would like to form a BGP neighborship between router 3 and router 5. Now the question is the which IP that you are going to use for your neighborship. Okay. So in this case, let me use 35. Okay, that means the interface gigabit 1/0 of router 3 and gigabit 1/0 of router 5, which are directly connected subnet for router 3 and router 5. I'm going to use the same IP addresses for my BGP neighborship as well. Okay, so here what I'm going to do, first I have to ensure that whether the reachability is there from router 3 to router 5 for the IP which I am trying to form a neighborship. Okay, so I'm on router 3, so the router 5 IP is 35005. If I hit enter, obviously we will have a ping response, right? Because it is directly connected. We do not need any kind of extra routing configuration to route the packets to reach directly connected subnet on that particular link, because router 3 know where the 35.0.0.0 is connected, so it is a locally connected route in the routing table. Let's check that. Here it is. So this is what our destination gets with 3500/24 network. It will be routed on this interface. So wherever neighbor is connected, the same apply for our neighbor as well. That is why we are seeing the ping response. That means we have the connectivity to 35005. So now we are good to start doing a BGP configuration for that neighbor IP. So let's start. This is router BGP, and the AS number here I am used just 35 for router 3. Okay, enter. And what I have to do here, okay, so before doing here anything, let me just do debug BGP all. Okay, let me give this command. So whatever relevant to BGP, let it start capturing that in the logs. Okay, so here I'm going to do a neighbor. My neighbor is who? 35005, right? And then I have to say where's my neighbor belongs to. So the remote AS of my neighbor is 35 again. That means it is both routers are belongs to same AS. That means it is a IBGP relationship, neighborship. Once I hit enter, okay, that's it you have to do. You do not have to do anything for you have not like there is no any extra configuration is required here. Okay, there are already some messages we could see once we hit that. Okay, active open failed. That means our we can here we can see the state neighbor state went from idle to active. Okay, we know why, because we haven't done the configuration on the other end. Just we are trying to explore what are the messages that we are trying to get it here. Okay, so that's fine here. Nothing is wrong. So let's go to router 5. Let's do that. Router BGP AS35, and my neighbor is 35003, right? And my neighbor remote AS is same, which is again 35. Before hitting enter, I would like to start capture a Wireshark on this interface. Okay, that's fine. Once I hit enter here, my adjacency is up now. Okay, do and debug all to stop my uh, syslogs. Okay, so let's get into Wireshark, what we are seeing over there. Let me stop this. Okay, and is our neighborship is up now? How to check that? There is a command show IP BGP summary. Okay, once you hit enter, you will see a neighbor information. This is also called as a neighbor table. Who is your neighbor? What is the neighbor version? What is the neighbor autonomous system number? And you ignore this part for time being. And we should see these two columns, up, down, and state or prefix received. Alright. If there is a timer here and if you see any number including 0, that means this timer is referring to up timer. Instead of number under state prefix column, if you see anything else other than the number, let's say active, idle, connect, then if you see timer here at that point, then this timer is called as a down timer, right? It is not a up timer. Okay. So let's go and see what happened exactly. Okay. In Wireshark, we can see that. Okay. See here, first I could see a TCP protocol relevant message. Here, let's open here, extract the TCP section, and you can see the source port is something 61905, which is a randomly generated source port number, right? And the destination port is 179. Okay, and this is from source. You can see the internet protocol, right? The source from dot 3 to dot 5, that means router 3 to router 5. And router 3 port number is 61905, and it is sending this message to which port? On port 179. Why 179? Because BGP port number is 179. This is always a destination port number, it cannot be a source port number. Okay, when you see the next message here, uh, what happened? Okay, when you see on this message, now the reply is coming from router. Sorry. Okay, that is the fifth message. Now there is a initially the message went from router 3 to router 5, which is a TCP, and if you see the flag, it is mentioned as SYN, right? There are many flags under this subsection like sync, fin, reset, push, acknowledgement. For time being, for this particular process, currently it is set as SYN at this moment, right? When you see the next message, there is a reply coming from router 5 to whom? To router 3. How I'm knowing that? The IP which is ending with dot .5 is router 5. The IP which is ending with dot .3 is a router 3. And this is again a TCP message. And if you see this here, we have the source port 179 and the destination port 6195, right? And I have told you that 179 is always a destination port, it cannot be a source port. What does it mean? Okay, for example, let me clear all these things if you guys are getting confused with what I have said. Okay, there is two routers who is trying to form a BGP neighborship. It doesn't mean whether it is IBGP or EBGP, whatever it is. Let's consider it as router 1, router 2. When router 1 is configured for the first time with router BGP, neighbor statement, neighbor IP, remote AS, and let's say the AS is remote AS is 200 and my local AS is AS 100. Okay, once that is done, router 1 will try to establish a TCP three-way handshake. That is what we have told. Okay, that means how router 1 will communicate to router 2. Okay, because here we have mentioned, right, what we have mentioned, what is our neighbor IP. Let's say the neighbor IP here is we are using 12.0.0.0/24 network. Here my neighbor IP will be dot 2, my local IP will be ending with dot 1, right? So here, when it is trying to send a TCP message, okay, the destination IP would be 12.0.0.2 and my source IP would be 12.0.0.1 and my destination port would be what? 179 for the first time when it is trying to send a TCP SYN message. This is how it looked like, right? And my local port number, that is a source port number, would be a random port number which we cannot figure it out what it would be. Random port number. Okay. So when this message is sent from R1 to R2, now R2 has to acknowledge back, so that here the receiver will become, that means the will become the source address and the source address will become the destination address. Similarly, the port here, the destination port will become the source port and the source port will become the destination port. That means here let me put like here to whom I'm trying to send 12.0.0.1 is my destination address. And who is my source? It is 12.0.0.2. And to whom I'm trying to send? The random port number. Here the random port number means what we have, that means what R2 has received in the previous message during the TCP SYN message. Okay, and here the source port number would be 179, right? So here the TCP SYN ACK message would be going in this fashion. So that is what it is happening if you see in the Wireshark as well. Initially we are seeing 61905 as a source random source port number and 179 as destination port number, right? And when R3 is replying back to R5, see here, it is just something is wrong here. Okay, don't look at that packet. Okay, there is a reset acknowledge, that means the connection got reseated. Focus from the sixth message. Okay, here initially the random source port number is 6800 and the destination port number is 179 and it is a SYN message. How do I know? Because it has mentioned the flag here as a SYN. That is how I came to know it is a SYN message. When you look at this now, previously the message has gone from router 3 to router 5. Now router 5 is replying back to router 3. Here the source port number is 179, right? And the destination port number is 6800, which is exactly same what router 3 has used to send the SYN message as a source port number, right? So that is what it is happening. Now it is a SYN ACK and now router 3 is acknowledging back to router 5 on port number 6800 to 179 so that our three-way handshake of TCP is done, right? Once this is successfully, uh, once the three-way handshake is successfully done, then we will be start sending our BGP messages. Okay, what is this? We have seen there are four type of messages, which is open message, keep alive message, update message, notification message, right? Here we are not seeing notification. If there is something bad, then only we will be seeing the notification. Because still my neighborship is up, there is nothing wrong with my neighbor. So until unless we do not see anything bad with our neighborship, we will not be seeing the notification. So the open message, it says, where is that? Here is the BGP section. Let me open that. Here we can see what we are sending. What is here? There is a opcode. Here the code is number 1, open message code. That means here I'm trying to send the what is my version, which AS that I belong to, and what is the hold time, and what is my router ID. So router 3 is sharing this information to router 5. Once this information is looking good for router 5, so that router 5 can establish a neighborship with router 3, right? So this is what it is happening. Once router 5 is seeing router 3 is good, then they will start directly exchange the keep alive message, and they can exchange the routing table whatever they have new. So let's get into the CLI and see what exactly is here. We didn't see any kind of neighbor states in the Wireshark. Only we have seen a message, BGP messages, right? So here, the interesting part is, okay, initially the BGP state was idle. That means here the BGP uh, waiting for a peer so that it can start initiation. But in this state, it is idle. It is not doing anything, just waiting for its peer to come up. That means he's waiting for the neighbor to join the process for sending the BGP messages. Okay, now it went to active. Okay, okay, fine. I do not see any connect. What I'll do, let me just restart my BGP session. Before that, do sorry, debug IP BGP all and clear IP BGP start. That means I'm reseating my existing BGP neighbors. This command will tear down my existing BGP neighborship with router 5, and then the process will start from the scratch. Okay, so do not try this command in your production environment. This will create a huge impact. So whichever this router 3 is peering with, all the neighborship will go down, and then the BGP process will start from the scratch. So this creates a huge impact in the production network. Do not try this command on the live environment. Okay, I see the BGP neighbors up. So let me undebug all. Okay, so let's see. Here we got the reset. Okay, so from idle, the state is went to active. Here, our that means like we have seen during a connect neighbor state what happens. Our TCP three-way handshake protocol will be happening, and once it is successfully completed, then router 3 will be sending open message, right? In that open message, actually when it is sending the open message, it will be the state will be changing to open sent. Okay, what message is included in the open sent? We'll be having my AS number, and what is my router ID, and what is my BGP version, and what are the capabilities that I support. So these are the parameters that it will be including in that. If it is okay for my neighbor router, then he will be acknowledging me. In that point, I'll be moving from open send to open confirm, right? So here from active we have moved to open send. That means we have sent the open message to our neighbor, and we are waiting for our neighbor to send a open confirm. That is nothing but the acknowledgement for open sent. Where do we say that the state from open send to open confirm? Okay, here received open message. Okay, here we can see here I'm sending an open message. What is my version number? That is a BGP version number 4, and my AS, and what is the whole time that I support, and what is the router ID. Okay, here it is 3, the router ID here it is 3.3.3.3 it's supposed to be, right? Okay. It is nothing but a router ID. Let's check that what it is, no problem. And after that, uh, where do we see the open? Okay, okay. So here, once this message is being sent to a neighbor, once neighbor is okay with these parameters, let's say my neighbor is configured in the same manner that router 3 is from remote AS of 35, and it is also the version of 4, and the whole time also is getting matched, and the router ID is not there is no duplicacy with router ID, it seems to be unique. That means my neighbor router is good at that moment to form a neighborship with router 3, right? So once router 5 sees it is good, then it will send the acknowledgement. Once the acknowledgement is received by router 3, then the state will be moved from open send to open confirm, right? And during open confirm, we'll be waiting to receive a keep alive messages from our router. Okay, and also we'll be sending a keep alive messages to our neighbor router. Once we receive the keep alive messages from open confirm to, we'll be moving to established state where our BGP adjacency will be going up. So this is the process which will be happening in the background just by hitting this one command to form a BGP neighborship with router 5. Okay, there is a lot of information just to build single neighborship with router 5, right? So that is about this video, just to understand what is the process is happening in the background while establishing a BGP peer. In next video, we will be seeing how to configure iBGP and eBGP and what other parameters that are associated with those BGP configuration that we'll be looking into it. Stay tuned. Till then, bye now. See you guys.